This is the last lesson in our probability unit. It is on independent events. Independent events is when the two events are independent if the outcomes of one event does not change the probability of attaining the other event. When we did the tree diagrams and we did replacement of experiments, that was an example where it's independent. There are two tests to test if two events are independent. The first test is that the intersection of A and B is equal to the probability of A times the probability of B. If that's true, then the two events are independent. An alternative approach is this: if the probability of A given B is simply equal to the probability of A, then they're independent, or vice versa, if B given A is equal to the probability of B. When we do an example, this might be a bit clearer. So an example in your notes, you'll see we've got a selection of 10 mobile phones. Offers includes 4 free connection and 5 with a second free battery, while one offers both free connection and a free battery. So we need to define the events first. So the first one, we'll let C choosing mobile phone with a free connection, that's right, and B, the event choosing mobile phone with a free battery. Summarise the information in a Venn diagram in a two-way table. So the Venn diagram will look like this. There's 10 in total, 3, 1, 4 and 2 add up to 10. 4 with a free connection, there's 4 in the circle of C. There's 5 with a free battery, 5 in the circle of B. 1 offers both, so therefore that has to be 4 and that has to be 3. That only adds to 8, so there must be 2 mobile phone offers without a free connection and without a free battery. Two-way table, the same 4 numbers in those 4 spots as on the table here. That's the intersection of C and B. That's the C only, that's the B only, and that's the neither B or C. And we get our totals here. So we ask some questions. What's the probability of C? So there's 4 in C out of 10. So that simplifies to 2/5. Now the probability of C given B, there's 2 ways of looking at this. We could have given B, so that means we only need to consider this row here. And what's probability of C in this row? Well, C is 1 out of 5. State whether or not the events C and B are independent. Well, there's 2 ways we could have done that. The 2 tests on the previous page. The intersection of C and B is 1 out of 10. The probability of C is 4 out of 10 times the probability of B is 5 out of 10. That becomes 1/5. They are not equal, therefore they're not independent. Or we could have used the conditional probability answer we had up here. Probability of C given B was 1/5, and the probability of C was 2/5. They're not equal, therefore they're not independent. So you apply the test to see if things are independent or not. Either test will give you the same result. These are the questions you need to do from the following exercise. Thank you.